Welcome to Skillzam, a cure platform, cross-skill, upskill, reskill and expert skill. We are your best learning partner for life. Skillzam, keep learning. In this section, you will learn about decimal numbers and binary numbers. Also understand on how to convert a decimal number to binary. Decimal system. In the number system, each number is represented by its base. If the base is 2, it is called binary number. If the base is 8, it is octal number. If the base is 10, it is called a decimal number system. And if the base is 16, it is a part of hexadecimal number system. So, decimal numeral system, also called the base 10 positional numeral system and occasionally called decanary, is a standard system of denoting integers and non-integer numbers. The way of denoting the decimal number with base 10 is also termed as decimal notation. The base 10 or a decimal number system consists of 10 digits such as 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Each digit in the decimal system has a position, and each digit is 10 times more significant than the previous digit. Like for example, suppose 96 is a decimal number. Then 9 is 10 times more than 6. Base 10 representation numbers. Let us now understand with an example on how to represent a decimal numbers in a base 10 notation. Now consider a 4-digit decimal number. Each digit has a unique position, that is, in our example, 7 is in the units place, 4 is in the tens place, number 9 is in the hundreds place, and number 1 is in the thousand place. As you can go further with 10,000s place and so on. As already understood, every digit is 10 times more significant than the previous digit. Hence, digit in the units place is a multiple of 10 to the power 0. Digit in the tens place is a multiple of 10 to the power 1, that is 10, which is 10 times more significant than the previous units place. Digit in the hundreds place is a multiple of 10 to the power 2, that is 100, which is 10 times more significant than the previous tens place. Digit in the thousand place is a multiple of 10 to the power 3, that is 1000, which is 10 times more significant than the previous hundreds place. Going further, as you can see, 7 multiplied by 10 to the power 0, which is 1, gives a value of 7. In the same way, 4 multiplied by 10 to the power 1, which is 10, gives a value of 40. Again, 9 multiplied by 10 to the power 2, which is 100, gives a value of 900. Finally, 1 multiplied by 10 to the power 3, which is 1000, gives the value of 1000. Summing all the values will amount to the same decimal number of 1947. Binary system. A binary number is a number expressed in base 2 numeral system or binary numeral system, a method of mathematical expression which uses only two symbols, typically 0 and 1. The base 2 numeral system is a positional notation with a radix of 2. Each digit is referred to as a bit. The way of denoting the decimal numbers with base 2 is termed as a binary notation. Each digit in a binary numeral system has a position, and every digit is 2 times more significant than the previous digit. Like suppose, let's take an example. 1 is a binary number, then 1 is 2 times more significant than the previous numeral 1. So thereby generating a decimal equivalent number 3. Base 2 representation numbers. Let us now understand with an example on how to represent a binary numbers in base 2 notation. Now consider a 4-bit binary number. Each bit has a unique position. That is, in our example, number 0 is in the units place, number 1 is in the twos place, number 0 is in the fours place, number 1 is in the eights place, and you can go further with 16's place, 32's place, 64's place, and so on. As already understood, like every bit is 2 times more significant than the previous bit, hence bit in the units place is a multiple of 2 to the power 0, bit in the twos place is a multiple of 2 to the power 1, that is 2, which is nothing but 2 times more significant than the previous units place. Bit in the fourths place is a multiple of 2 to the power 2, that is 4, which is 2 times more significant than the previous twos place. Bit in the eights place is a multiple of 2 to the power 3, that is 8, which is 2 times again more significant than the previous fours place. Going further, as you can see, 0 multiplied by 2 to the power 0, which is 1, gives a value of 0. In the same way, 1 multiplied by 2 to the power 1, which is 2, gives a value of 2. 0 multiplied by 2 to the power 2, which is 4, will give the value of 0. Finally, 1 multiplied by 2 to the power 3, which is 8, gives a value of 8. So like summing all of the values will amount to a decimal number equivalent of 4-bit binary digit 1010, that is decimal number 10. So as you can observe that only 2 positional decimal number 10 will take 4 significant positions to store in a binary representation, but still binary numbers are essential because computer just understands only zeros and ones. Here you also understood a very important thing, that how to convert a binary values into a decimal number. Highest number represented by n bits. If there are n bits in a binary number, then the highest number represented by n bits can be determined by the formula 2 to the power of n minus 1. So now let us consider some good examples, like some scenarios for better understanding. Like if the number of bits in a binary number is 1, then the highest number that can be represented will be 1, whose binary equivalent is 1 as well. Consider another case, like if the number of bits in a binary number is 2, then the highest number that can be represented will be 3, whose binary equivalent will be 1, 1. If the number of bits in a binary number is 3, then the highest number that can be represented will be 7, whose binary equivalent will be 1, 1, 1. Finally, if the number of bits in a binary number is 4, then the highest number that can be represented would be 15, whose binary equivalent will be 1, 1, 1, 1. So, if we can meticulously observe the pattern, we can see that the highest binary numbers for the given n bits will always have 1 in the units place, and all the highest numbers are odd decimal numbers. Convert a number to a binary number. Now let us learn how to convert a decimal number to a binary number. For our understanding, let us consider a decimal number 25, which means 5 in the units place and 2 in the tens place. As we need to convert 25 to base 2 number, that is binary number, So divide this number by 2, that is 25 divided by 2 will be 12 with a remainder 1. Then 12 divided by 2 will be 6 with a remainder 0. Further, 6 divided by 2 will be 3 with a remainder 0. Finally, 3 divided by 2 will be 1 with a remainder 1. Finally, what we can see here and observe, decimal number 25 in binary is equal to 11001.